Welcome to ISCFDC EZOpt tutorial. In this tutorial, we will learn about the Analyze window and the analysis tools EZOpt has to offer. Let's click on the Analyze tab. This is the Analyze window. First, you'll notice that two new options have been added to EZOpt's toolbar: Create and Window. Under Create, we have the options to create tables and graphs. Under Window, we have the options to rearrange the tables and graphs into tiles or a cascade. To the left, we have the Analysis Data panel. In this panel, we will have the list of cases we ran. Each run will create a new case with a default results table called Main Results nested under it. To the right, we have the Properties panel. From this panel, we can control, for tables, the name, not to be confused with the display name, the filters we impose on them, such as range filters and Pareto font, the selected data, which parameters will be shown and which won't be shown, and change the colors, font, format, and display precisions of the cells. For the graphs, in addition to the options we have for the tables, since they are created using the data in the tables, we can also change the labels of the graph, title, legend, and axis names, change the axis display, like tick marks and minimum and maximum values, change the markers display, size and color, change the graph's theme, and change the type of the color map, if we are using a graph with colors. To show how to do all of the above, we first need a set of results to work with. We'll start by creating a basic workflow with 3 inputs, 3 calculators, and a constraint node. Now we'll create 3 independent branches. Let's set them up. For the first branch, change the name of the input to x1 and change its range from 0 to 1 to 0.1 to 10. Connect the input to a calculator, change its name to 1 over x, and write in the calculator's expression 1 divided by x. Finish this branch by connecting the constraint node. We'll set it up so that inputs greater than 9 will be considered as not feasible by changing the constraint to less equal than, value to 9, and write x1 in the expression. For the second branch, change the name of the input to x2 and its range from 0 to 1 to 0 to 20. Connect to a calculator, change its name to x, and write in the expression x2. For the third branch, change the name of the input to x3 and its range from 0 to 1 to 0 to 10. Connect to a calculator, change its name to x squared, and use the power function to enter the expression pow, open brackets, x3 to close brackets. We'll set up a DOE by using the Latin hypercube option. Choose the number of regions to be 1 and the number of designs to be 1000. Click OK and go to the Analyze tab to run the workflow. When the run starts, you will notice that a new empty case called Case 1 was added to the Analysis Data panel with the word running in brackets. The word in brackets is the status of the case: running, stopping, stopped, or done. During the case's operation, the main results table will update every few seconds with the newest results. When the case finishes running, the case status changes from running to done. If we click on the case title, we can see the case information in the Properties panel. We can give it a name, This won't change the title. See its status. Open the directory to see where we ran it, and see the DOE and algorithm we set for the run. If there are any errors, we can see them under Run Information by clicking on the question mark icon. These errors can only occur when using optimization algorithms. Above the cases information, next to the execution title, we have two icons, Stop and Play, and Pause when the case is running. We can use this to stop or pause a running case. Resume a paused case, add designs to the DOE of a completed case and rerun only the added designs using the redo append option, or rerun the DOE from scratch using the redo clean option. The main results table will contain all of the parameters in the main workflow with the addition of a design number. If an optimization algorithm is used, a generation column will also be added. The default order of the parameters in the table is inputs, outputs, and then calculators, with the order inside each group being decided by the order of nodes being added to the workflow. We can change and edit an existing table. We'll show that later in this tutorial. Here, we can see that we have some red lines. That is because of the constraint node we set up for the first branch. It turns the entire line red, even though the other branches are not connected to it. Now, let's say that we made a mistake, and we accidentally deleted the case we wanted to analyze, or we opened EZOpt and wanted to see the results of a case we already ran. To do that, we can import the results of a case. To import the results of a case, go to EZOpt's toolbar, click on File, and select Import Results. Navigate to the directory where the case's designs are, the directory with all of the numbered design directories and the proj.dat file, and click Open. This will add a new case to the analysis data panel, with the default main results table nested under it. We can import the same or other results as many times as we want, which can be useful when we want to compare results from different runs, or even from the same run but with different filters. The state of the analysis window, the cases we ran, imported, and the tools we created are saved with the project each time we click Save. So if we don't want to recreate them, we will need to open the project instead of importing the results, since importing the results will only bring a new case with the default main results table. Now that we are more familiar with the Analyze window, we can start showing how to use the analysis tools EZOpt has to offer. EZOpt has 4 categories of analysis tools, and they are tables, scatter graphs, parallel coordinates graphs, and correlation matrices. Any newly created tool will add a new line nested under the corresponding category in the analysis data panel, tables under tables, matrices under correlation matrix, and so on. While we can use any and all analysis tools to analyze the results of our runs, parallel coordinates and correlation matrices are a bit different. These two tools are usually used to analyze optimization process results, since their main focus is to show us how does one or more parameters affect the values we set up as our target values. More on these tools in subsequent tutorials. Let's create one tool from each of the categories. We'll begin by creating a table. In the EZOpt toolbar at the top, click on Create and select Table. A new window will open. In this window, we select under which case we create the table and which data will be shown in the table. Since we had the main results under case 2 highlighted, the new table was set by default to be created under case 2, meaning highlighting a case or a tool under a case will set that case as active. It is very important to check which case is shown in the analysis dropbox field, so we can avoid making a mistake and creating tools under the wrong cases. Change the case in the analysis field to case 1. Now, we'll take a look at the data sources from which we can choose. Here we have 3 categories: design data, node values, and node times. Under design data, we have the design number and feasibility. When using an optimization algorithm, another row will be added, generation. Under node values, we have main and our workflow, with the values of all of the nodes in the main workflow. Those are only nodes that hold values, like calculators and inputs. If we would have a procedure, it will be nested under main and have its nodes nested under it. And under node times, we have all the nodes in the workflow, including modify, loop, and exit nodes. Here as well, if we have a procedure, it will be nested under main with its nodes nested under it. For this table, we'll select the design number and the values of x1 and 1 over x. The numbers showing next to the parameters we chose signify the index of the column. After clicking OK, a new line will show under case 1's tables, with the name, table, and the fields we chose in brackets. If we'd like to add, remove, or rearrange the columns in the table, we can click on the table's title in the Analysis Data panel, click on the Settings icon next to Select Data in the Properties panel, and change the selections and the selection order. The next tools are tools that are linked to a table. Deleting a table with items linked to it will also delete the linked items. Deleting a linked item, like a 2D scatter graph, will not delete the table it is linked to. Imposing a filter on a table will also impose it on all of the items linked to it. The next category is scatter graphs. This category contains 2 tools, 2D and 3D scatter graphs. Let's create a 2D scatter graph using the table we just created. Go to the toolbar, click Create, go to Scatter and select Scatter 2D. This will open a window to create a new 2D scatter graph. In the new window that opened, we first select in which case we work and from which table we take the data. Select case 1 and the table we just created. Under node values, select x1. An x will show in brackets next to x1. This means that x1 will be the graph's x-axis. Then select 1 over x. This time a y will show in brackets. Click OK to finish. New categories named Scatter and Scatter 2D will be added to the Analysis Data panel, with our graph nested under them, and a new graph window will open. We can zoom in and out in the graph with the mouse wheel. Zoom to a selected area by left-clicking and dragging, and reset back to default value by clicking on the mouse wheel. Now our table has a linked item. If we right-click on the Data Analysis panel on our table's name, we will see Linked Items 1, and inside we can see our graph. If we click on a linked item from this list, the linked item will be brought forward. 2D scatter graphs can also have a third value selected. This value will be titled as color and will change the color of the data points on the graph according to the parameter chosen. In that case, a color bar will show next to the graph. The color bar type can be changed from the Scatter 2D tab in the Properties panel. Let's create similar graphs for the other branches from the main results table. Imposing a filter on a graph will also impose it on the table it is linked to. However, as mentioned before, imposing a filter on a table will also impose it on all items linked to it. so it is best to separate tables if we are planning on using different filters for different graphs. In scatter graphs, we can add another data source to compare results from the same case or different cases. To do that, we go to the Properties panel, click on the plus icon at the top right, and select the required data. It will then show on the graph as a second data source. The newest data source will always show on top of the earlier ones, so changing the marker size and color of the data sources will help distinguish between them. To edit the data sources, select the number of the data source and change it according to your needs and likings. Let's edit this graph by using the options we mentioned at the beginning of the tutorial, so that it is easier to read and understand. The next tool is a 3D scatter graph. Creating a 3D scatter graph works the same as a 2D scatter graph, but with the third parameter being the z-axis. Here, the fourth parameter chosen will be the color. From case 1's main results table, we'll select x1, 1 over x, and feasible as our x, y, and z respectively, and click OK. Usually, the z-axis points upwards. In our case, the z-axis points outside the screen, since the graph widget we are using is set up that way. To change it, we can swap between the y and z parameters when selecting the data. Turning the graph will not result in a correct orientation, again, due to the graph widget we are using. We can zoom in and out using the mouse wheel, and we can also turn our graph by right-clicking and dragging the mouse around, but we can't click on the scroll wheel to reset the view. Let's test what we mentioned earlier about deleting linked items and tables. We'll start by deleting the 3D graph, then the main results table, and see how each affects the case results. We can see that deleting only a 3D graph didn't do anything else, but deleting the main results table also deleted the graphs that were linked to it. We can recreate the main results table by ourselves, but it will have a name similar to the remaining table, brackets with the field names. So instead of doing that, we will use the table from case 2 to show the rest of the tools EZOpt has to offer. The third category is the parallel coordinates. Parallel coordinates creation also works the same way as scatter graphs, but with up to 10 available values. This graph is used to study the connection between parameters. For example, studying a black box function where we only have control over the inputs. We can also use this tool to qualitatively examine the correlation between inputs and outputs and other parameters. Let's import the results of the isPrime example from our previous tutorial about loops and use them with this tool. We'll choose from the new case added input 1, denom, and sqrt input 1 and click OK. If you do not have these results, you can follow the process with the results from this run and choose x1, 1 over x, and feasible as the parameters instead. We can see 3 columns with the titles being the parameters we chose. The only global options we have for this graph are the theme, line width or thickness, and tick count. Since this graph has so many available parameters, we can't edit everything from the Properties panel. Instead, we can right-click on the axis title and change it from there. Set color will set the selected axis parameter as the color and add a color map to the graph. To remove the color, click on the settings icon next to color coordinate and uncheck the selected parameter. Then click OK and the colors will be removed. Reverse axis will reverse the axis. Looking at the zoom options, zoom range will change the maximum and minimum values of the axis, while zoom extent will return the axis maximum and minimum back to their default values. We can also zoom in and out by scrolling the mouse wheel and zoom back to default by clicking on the mouse wheel. To impose filters on this graph, we left-click and drag. This will create a type of a selection box on the axis. Clicking on Zoom Extent or mouse wheel will zoom into that selection box. To remove the selection box, which is a filter, click on the setting icon next to range filtering and remove the filter. Note that all of these operations are carried out per axis and not for the entire set. The last category and tool is the correlation matrix. Choose X and 1 over X and click OK. This tool creates an n by n table, n being the number of selected parameters, here we chose 2, which uses colors to show how does one parameter correlate to the other. In our case, how does x1 correlates with 1 over x. The default colors are blue for positive correlation and red for negative correlation. If you check how one input correlates to another input, which they shouldn't because they are independent from one another, EZOpt will still try to find a number to show the correlation, but it will have no real meaning. For all of these tools, the left tab in the Properties panel is Data, in which we can change the selected data, impose filters, and exclude designs. The right tab, Name Changes according to the tool, will have options specific to that tool, like axis name for graphs or cell color for tables. This is it for this tutorial. Thank you for watching.